see if I can get it up on the screen there for you. So these are all mostly the graphing problems. A couple of them you guys had on your 3-1 to 3 quiz, which got back already, so you can look over that. But there's going to be a quadratic, there's going to be a polynomial, and there's going to be one that's a rational function, like we practiced yesterday. And then there'll be a couple smaller division problems, but 5 problems total for the first day basic calculator. So they're going to look really similar to what you've got in front of you there. And then, like always, you guys have all those extra practice problems in Polaris too. So if you go to the test review folder for Polaris, you guys can see day 1, and there's like, I think like 2 or 3 of each type of problem. And then day 2, 2 or 3 of each type of problem that you guys can look through and practice on your own, in addition to this chapter review and the math Excels you're already doing, if you want to. Okay? All right, let's get started. Okay, so part 1, basic calculator only. First problem is our quadratic problem. All right, so we got to find all the pieces and parts and graph it. Holden, what's wrong with this equation?
It's not in the right order.
It's not in the right order. So let's put it in the right order first. Negative 2x squared plus 12x minus 14. And the first thing that I would do is find the vertex. What's the little formula that we use to find the vertex? Negative b over 2a. All right, so negative b over 2a. That one's easy to remember because it's in the front of your quadratic formula. What's the opposite of b? Negative 12. And then 2 times a is negative 2, so we're going to have negative 4 on the bottom. Negative 12 over negative 4 gives me 3, okay? If I want the y that goes with that x, what do I do? What do I do? Plug it in, yeah. So y equals negative 2 times 3 squared plus 12 times 3 minus 14, and you'll have a graphing or a basic calculator for this at least. So let's see, that'll give me negative 18 plus 36, that's a positive 18, minus 14 is 4. So my vertex is 3, 4. The other thing that I would do right now is put this quadratic, even though it doesn't ask you to, into standard form with the parentheses squared. As soon as you have the vertex, remember that's your h and k. So you can take the equation and write it like this instead. That negative 2 is still going to be in the front. That a value doesn't change. But it's x minus h, so minus 3 squared plus k plus 4. You can also complete the square to get that, but I would say that you are going to be far more successful just by finding the vertex and plugging it in versus try to do all those completing the square steps. Those of you that tried to do the completing the square steps, it didn't work out so well, I think, on the quiz, so I think this would be the better option if you want to get in that form. Okay, once we have vertex, axis of symmetry should come quickly. The only thing I want to remind you of is there better be an x equals in front of it. This is a line that we are writing the equation of. It's always going to go through my vertex, so x equals whatever the x-coordinate of the vertex is. X-intercepts are easy to find if you've got it in that standard form. So 0 equals negative 2 x minus 3 squared plus 4. It's easy to find it in this form because I don't have to use the quadratic formula. There's just a single x. I'm going to get it alone. So I'm going to start moving things to the other side. Subtract 4. Then divide by negative 2, so that's 2 equals x minus 3 squared. Then take the square root. Don't forget your plus and minus. So plus and minus, rad 2 equals x minus 3. And so my final answer for x-intercepts are positive 3 plus and minus rad 2. And you can just leave them like that. In your basic calculator then, if you want a decimal approximation for those, you could get it 3 plus rad 2, 3 minus rad 2 to see where you're going to plot them on the x-axis, but you probably won't need those. Y-intercept is when x is 0. I think it's easy to use the original equation for the y-intercept. 12 times 0 minus 2 times 0 squared minus 14. You can see pretty quickly we get negative 14. Which way is this going to open, up or down? It's going to open down, and how do I know? Yes, because the a value is negative in either of the form of the equation that I look at. And then if it opens down, does that mean I have a min or a max? I have a max. Good. Okay, so now let's put all this together and get a graph. And when in doubt, if your graph doesn't look like what you think it should look like, what could you do? Just make an XY table and plot points. All right, so I have the vertex at 3, 4. I know it's going to open down. I have a y-intercept at -14, so that's going to be like way down there somewhere. That is enough to get a picture of it. You can, because that's kind of far off the graph, again, if you want, get those approximations for the x-intercepts. If I do 3 plus rad 2, maybe we'll do that, about 4.4. And if I do 3 minus rad 2, I get about 1.6. So that can help you get the width a little bit. There we go. Okay, should be symmetric. Make sure you put arrows on it. Don't lose points for silly stuff like that. Okay. What questions do you have on the parabola problem? All the little pieces and parts. Okay. Let's do the polynomial one. All right. Okay, this one is mostly factored for us already. Can I factor this anymore? What can I factor here? There's something. Yeah, that is difference of squares. So let's go ahead and do that. That factors to conjugates, x plus 2, x minus 2, and I'm going to write the x plus 5 twice. That's what that parentheses squared means, but you can just write it in the condensed form if you want to also. Okay. End behavior. In order to find the end behavior, you need to know what the leading term is. Now, this is the only bad thing about it being in factored form is it doesn't just outright give us the leading term. We have to figure it out. So we had problems like this in class. What we did was we took the highest degree term from each parentheses and just multiplied them together. So I have -4x times 4 more x's. So the leading term, if I FOIL this guy out, would be -4x to the 5th. And you can see it's a degree 5 because there's 5 factors there, but the -4 is that leading coefficient that we need. If it's -4x to the 5th, can you sketch one of the 4 shapes, both up, both down, opposite directions? Which one's it going to be? What do we think? Opposite directions? Is it going to go up from left to right or down from left to right? Down from left to right because it's negative. That guy is what we're looking at. So you need to know those 4 shapes. Okay, so it's going to look like a cubic that's been reflected. All right, when you list your end behavior, I want to see the limit notation that we've been practicing. Okay, so the limit as x approaches -infinity and the limit as x approaches positive infinity of our function p of x equals, oh, I didn't get myself enough room there. Limit x approaches positive infinity of p of x equals, and I won't, if you don't have the p of x there, I'm not going to mark it wrong. We're just trying to stay consistent with the notation that the calculus classes use. But I need to see limit, I need to see x approaches -infinity, x approaches positive infinity. So we're just worried about the 2 ends on the left and on the right is what this means. On the left, what's it approaching? Positive infinity on the left, and on the right, it's approaching -infinity. So these are just infinities with our polynomials. On the left, it's doing one thing, and on the right, it's doing another, either positive or negative infinity. So everything's going to look the same, except what it's equal to will change based on where your ends are going. Okay. All right, zeros in their multiplicity. We already factored it. So we just have to name the zero. Set each zero or each factor equal to 0. If I set -4x equal to 0, what do I get? 0. If I set x plus 2 equal to 0, I get -2. If I said x minus 2 equal to 0, I get 2. And if I said x plus 5 equal to 0, I get negative 5. All of them have a multiplicity of 1 except for this guy has a multiplicity of 2. And these ones have a multiplicity of 1. Okay. Y-intercept, we're just going to plug in 0 for x. So negative 4 times 0. 0 plus 2. 0 minus 2. 0 plus 5. 0, or yeah, plus 5 again. There we go. All right, simplify everything. Negative 4 times 0 is 0, times 2, times negative 2, times 5. Just simplify in each of those parentheses, times 5 again. Well, I have 0 times a bunch of stuff. So it is 0. Maximum number of turning points is what? How do I find that? Degree minus 1. And what's my degree? That leading term again can give that to you. Minus 1 is 4. Sign analysis. We'll come back to this. This is optional. I will not require that you do that. Okay? All right, so let's plot everything we know. Let's start with the zeros. Those are places where it's crossing the x-axis. It touches at 0, at negative 2, at positive 2, and at negative 5. So there's 4 places. We also have a y-intercept of 0, but that's already plotted. On the left, I know it's going to go up, and on the right, I know it's going to go down. Matches my end behavior. I'm going to go through all of those points except which one? Negative 5. At negative 5, when I get to that point, what do I have to do? Turn around. Okay, so here's what it looks like. Remember, the part of the sketch we don't know without plugging in more points is how high the hills are and how low the valleys are. That's just a sketch. But I want to see that your ends match up, and at each 0, you're doing the right thing. You're either going through it or turning around. This is the one where we turn around. We don't know how high it goes, but we need to get back on that hill to negative 2. Then it goes through, 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 and down. Okay, again, your valleys and your hills, if those are different heights, that's okay. If you did sign analysis, which again is optional and I will not require, that's basically a way to check this answer. You take your zeros, negative 5, negative 2, 0, and 2, and you plug in numbers in each of those intervals. And you are concerned about whether it's positive or negative. Positive, positive, negative, positive, negative is what you would get if you plug in numbers in each of those spots. So this actually checks a couple things for you. If you look on the ends, it actually gives you the end behavior. It's telling you on the left it goes up and on the right it goes down. It's also saying between negative 5 and negative 2 it's above the axis, below the axis, above the axis. It tells us where it's above and below. You can even see if you have 2 signs that are next to each other, when it turns around, it doesn't go through. Okay, so if you're not sure, take your zeros, plug in some numbers, and the positives and negatives will help you sketch the graph. That's what this is for, but you really don't need it if you've done everything correct and you kind of understand the relationship between the points and the end behaviors at the top. All right, questions on number 2, big polynomial graph. All right, one more graph. It is a rational function. Okay, so it doesn't say this to start, but what's the first thing we always look for? Ooh. We factor it. Okay, let's do that. The numerator, can I factor that at all? Take out a 2. We'll start with that. Sure. That leaves me with x squared plus x minus 6. Okay, what about the denominator? Does that factor? X plus 4, x minus 1. Does anything factor anymore? Maybe the numerator again? What would the... That'll work. Positive 3, negative 2. Does anything cancel? Does anything reduce? So what does that mean? No hole. Yay! Okay, x-intercepts. Where do we get x-intercepts from? From where? Y equals 0, and there was a shortcut yesterday. The numerator equal to 0. So if you set your numerator equal to 0, that'll give you your y or x-intercepts. Okay, so my numerator, we already factored it, so we saved ourselves some time here. Numerator equal to 0. What are my 2 x-intercepts going to be? -3, +2, and I'm going to graph them. -3, +2. Okay. How do I get a y-intercept? 0 in for x. And I would actually use the original equation for this, because I think it makes it really easy to see what's going to be left after you get all those zeros in there. But you could use the factored one too. What am I going to be left with when I plug 0 in that original equation? I'm going to have -12 over -4. Yep. So my y-intercept is 3. Graph it. Okay. Vertical asymptotes, where do those come from? Denominator, which we already factored, equal to 0. What are the vertical asymptotes? Good. And make sure anytime you're listing an asymptote or like the line of symmetry, there better be an equation, either x equals or y equals. Vertical asymptotes are x equals, horizontal asymptotes are y equals. All right, let's graph those. So at x equals 1, I have a vertical asymptote, which I'm not going to be allowed to cross. And at x is a -4, I also have a vertical asymptote that I'm not going to be allowed to cross there. Okay. All right, horizontal asymptotes, what do we do to find those? Do you remember? N and M, and we want to find the relationship between them. Here they are both equal to 2, so these are your powers. If N is equal to M, yes, that is when we divide whatever the leading coefficients are. So not the degrees, but the numbers in front of the leading term, which in this problem are a 2 and a 1. So we do y equals 2 over 1, y equals 2. Make sure you know all 3 cases of that problem, okay? So what if n was less than m? What would be our answer? N is less than m. Y equals 0, I think I heard somebody. Yep, n is less than m, it's y equals 0. What if n is greater than m? It's oblique instead. So it's either one or the other. So as far as oblique goes, there are none. Okay. And I'm going to graph y equals 2 right there. Am I allowed to cross a horizontal asymptote? Yes. Am I allowed to cross a vertical asymptote? No. All right. Last thing I need to do is make a few extra points. It says at least 3 additional points. That means don't use x-intercepts and y-intercepts. We already know those. We want additional points beyond what I've already graphed. So I'm going to pick a number smaller than -4 so I can see what's happened on like the left side there. So like I'll use x as -5. I'm going to pick something in the middle like -2. I don't have a value for, bless you. And then I'm going to pick something on the right side, maybe like 5. Okay, it doesn't have to be those exact numbers, but pick something on the left, in the middle, and on the right that you don't have values for already. Then we're just going to take those numbers. You can use the original equation, it's fine. You're going to have your graphing calculator, or basic calculator, but simplify the numerator, simplify the denominator, and then just reduce the fraction if you can. A lot of times it just doesn't reduce, so just think of the numerator and denominator as like separate places you're plugging it in. All right, so mental math here. So let's say I plug -5 in the numerator. That's going to give me a 50 minus 10 minus 12. So that's going to give me a 28. If I plug -5 in the denominator, that's 25 minus 15 minus 4, which gives me 6. So that is approximately 4 point something. 4.6 repeating. Okay, so we'll just say 4.6. That's fine as far as graphing goes. We have the exact answer there. All right, -2, plug it in the numerator. That would give me an 8 minus 4 minus 12. That's -8. Plug -2 in the denominator. That's 4 minus 6 minus 4. That's -6. So that would be 8/6 or 4/3 or about 1.3. 1.3 repeating. Okay. And then plug 5 in the numerator. That's going to give me 50 plus 10, which is 60, minus 12 is 48. Plug 5 in the denominator. 25 plus 15, that's 40, minus 4 is 36. So that is 1.25. If I reduce that, yep. Either one, because they're the same. So whatever you want to use in your calculator is fine. Good question. Okay. Everybody okay getting those? And worst case scenario, just make a bigger table if you're not sure what it looks like after we plot these. All right, so remember on the ends, on the left and on the right, it's going to look like an L shape. You just have to figure out, is the L at the bottom or is the L at the top? So -5, I'm at about 4.6 up there, maybe, something like that. Maybe a little lower than that, that's fine. But that's enough to tell me, okay, that little part is going to be in that region that we created. Okay. And +5 on the other side, I'm at 1.25. And we already had that x-intercept. So for sure, that's enough to tell me it's going to look something like that. Okay. And then remember, in the middle, it's going to be one of our 4 cases of end behavior. Either both ends go up, both ends go down, one goes up, one goes down. You can see here for sure we're going to cross through the horizontal asymptote. From these points alone, can look at this and say, okay, for sure it's going to go down on this side and up on that side. It's not going to turn around because I don't have another place where it's crossing the x-axis. So I have enough there, but that extra point just, kind of confirms what I'm thinking. So -2, I'm at 1.3, and then again, you can see it kind of looks like that cubic shape in the middle. Okay, and then remember, if you did have a hole, you would just plot a single open circle at that point, wherever it was. Okay. Questions on rationals, graphing? Okay. Last 2 problems. Oh, and I think you're almost done. If you want to finish it up. Okay. All right, last 2 problems. Find all the zeros given that 1 0 is 3i. If they give you a 0, that means you have enough to work backwards and divide it out to get what we're missing. If 3i is a 0, what else is a 0? -3i. And if I have zeros, I can write factors. What are the factors? X minus, yep, we pretty much put an x minus in front of both of these. So x minus 3i, x plus 3i. And then what can I do with those 2? Multiply. And this is one that's not too bad because it's just 2 terms times 2 terms. We did ones in class, if you remember, that were 3 terms times 3 terms, which is a little bit bigger of a foiling. You'll see some of those in the extra practice. If I FOIL it out, I get x squared. They're conjugates, so outside and inside cancel. Minus 9i squared. Do you remember what I squared is equal to? -1, so it's going to be x squared plus 9. Okay, that is a factor because I used factors to create it. So I can factor it out by using division. Because it's a quadratic, though, we have to use long division. The good news is you're going to know if you're doing it right, because what should happen in my long division if I divide out a factor? Should be no remainder, 0 remainder. Okay, so let's do that. X squared times what gives me x to the 4th? X squared. Multiply it by the guys on the side, I get x to the 4th plus 9x squared. Subtract. First terms cancel. Bring down my negative 2x to the third. Careful with the subtraction here. It's a negative 6 minus 9, so negative 15x squared, minus 18x minus 135. Do it again. X squared times what will give me negative 2x to the third. Negative 2x times the guys on the side are going to give me negative 2x to the third and negative 18x. If I subtract in both of those sets, it's something minus itself, so they're both going to cancel. Just bring down what I haven't used yet. Negative 15x squared and negative 135. X squared times what? Bless you, will give me negative 15x squared. Negative 15. Negative 15x squared. And surprisingly, 9 and 15 are going to give me 135. Subtract, I get 0. Okay, this problem said find all the zeros. So here is what we have done. We have factored our original function into two factors, x squared plus 9, what we divided in, and x squared minus 2x minus 15, our quotient that we got out. X squared plus 9, you can set it equal to 0 and solve if you want to, but we don't need to because we know the solutions from it are plus and minus 3i. We use the solutions to create that quadratic, so don't waste your time trying to solve it. The one that we don't know the answers to is this x squared minus 2x minus 15, which can factor to what? X minus 5, x plus 3. So the other two answers I'm going to get from that guy are x equals 5 and x equals negative 3. On the test, let's say you have extra time and you want to check this. You can plug both of those in and you should get 0. Or you could synthetically divide them out and you should get 0. You can check those last two answers as long as they're real numbers. All right? Do you need a pass on?
Yes, please.
Okay. Questions on that one? That's a big problem, lots of steps. All right, last one. Is the last one the synthetic division one? Easiest one. There you go, yes. All right. Determine if x minus 2 is a 0. There's a few different ways to do this. I would say the easiest way to do this is with synthetic division. What could I divide in if I want to check synthetic division? I'm checking that x minus 2 is a 0. 2. If it's a 0, what should happen? No remainder. So let's see. Bring it down. 2, multiply 4, 7, 14, 13, 26. My remainder is 27. So is it a 0? No. And it says show work and explain. We showed our work. Check. Explain. Why? The remainder does not equal 0. Okay. The other way to do this is you could plug 2 into the equation if you want to, and you can use your calculator for that, and you will get out 27. It gives you the remainder that way. Again, the explanation is still no, the remainder is not 0. Okay, that's Friday's test. 3 graphs, 1 long division, 1 synthetic division. Tomorrow we're going to do part 2. Tonight, your 3-5 Math Excel is due if you've not finished that yet. You could also work ahead on part 2 if you want to before we do it together tomorrow. That's optional, up to you guys, okay? So last 15 minutes are yours. You can work on either of those things, and then we'll come back together tomorrow and do the second bit. All right? Good. I'll do cell phone lotto for you.